Recently, I have been trying to introduce AI more and more into my personal life. Therefore, I went through the popular services, checked their APIs, and saw their pricing. First, let's see the pricing for OpenAI. So this is their API pricing. This is different than the consumer. And for example, if you want to go with GPT-4o, you have to pay $2.50 per million token. Each token is going to be the words that is going to be processed. The input is whatever you're going to ask. The output is going to be the answer of the model. And if you go for GPT 4.5, then you have to pay $150 per million tokens. It's pretty expensive. Well, this is now the pricing for Grok. As you see, the pricing is also a little bit high. It is also calculated per million token, and the output is $10 and $2 for the input. It's a little bit cheaper than OpenAI, but still I would consider this expensive for a home project. The third option is perhaps DeepSeek, but I mean, beside pricing, I also care about security. I rather not to use anything on the cloud for a personal project, for example, a home project like this. And I definitely don't want my data to be processed by this guy and definitely not this guy. So I would say, let's just see how can we build this by ourselves. While I was gathering information and doing my research, I encountered Ollama. Well, Ollama basically is just a model registry, like container registries or package registries. People come, train their model, push their model into Ollama, and you can just start using that model based on the documentation. There is an SDK for Ollama which you can use in Node.js, in Python, and in .NET, as I also saw. It is cross-platform, so you can use it with Windows, Linux, and Mac. Most of the models here you can use even with older graphic cards. I managed to use the DeepSeek LLM 7B on an old GTX graphic card. It was slow, but it was running fine. Maybe I couldn't do 10 parallel requests, but it was getting the job done. But today we are going to actually go on and then pull the Ollama 3.2, and a 3B model definitely gonna work in most graphic cards. The B here is the billion parameters that has been used to train the model. So this is 3 billion parameters has been used to train this model. The higher the number, this means the model is more complex, but it doesn't mean that it is smarter, of course. Like the higher the number, it's smarter, but the low number also doesn't necessarily that it is like dumb. No, because maybe it has been trained by those parameters for one specific task and it just does that task perfectly. Yeah, so this is the case with the models, and as we go on in the videos, in the next videos, we are going to see how can you combine different models with different parameter loads to see how you to build and use and build an intelligent cluster. Now let's go on and see how can we use this 3B model. So let me go on here and pull this model. For pulling, I'm not going to run. Let's just call the pulling. So now that the model is pulled, well, it is offline. So it is good to run your model offline. Now you can actually take this model file and put it in an object storage and use it for deploying your application into Kubernetes. Now, where is this stored? So in Linux, the model is stored under user share. And here, if you search for Ollama, then here you will see the models and the manifests. As you see here, I can find the Ollama manifest. If you open it, it just basically have the information of where does it find the binaries. So the binaries are in here. So these are the blobs, and you can just take these and then put them into an object storage and run your application in a container. Now let's check how can we use this model in a Node.js service. Here I have created a Node.js application in advance. It is a simple Node.js service with Express. The reason that I have done this in Node.js is that there are so many examples with Python that it brings this up to the mind that, okay, for AI, I must go with Python. But this also doesn't mean that you should not learn Python. For training, definitely you have to go with Python, that we are going to show in the next videos, how you can train your own model from scratch for different use cases. But here we are going to see how can we use this and stream our response from the model to the UI. Well, in this case, what I have here, the only difference that this service may have is that under my chat handler, which is called from my chat endpoint under this controller, I am streaming my response to the client. So I'm using the response.write in Node.js, and then under OpenStream, I am setting the content type to event stream and flushing the headers immediately as the request is opened, so the UI knows that it has to wait for a stream, or like the client should know that. And let's actually try this in action, see what I mean. So as you see now, it doesn't wait for the answer, but it just streams it character by character, and it simply just is telling me hello world. But now the plan is to replace this and integrate Ollama here. Well, Ollama has a package already for Node.js and it supports TypeScript. Let's just go on and install this in our application. And let's actually go through the documentation, because it has a pretty good documentation here. As you see, we need the Ollama object, and this is how we are going to do the chatting with the AI. You have to put the name of the model and the message that you want to send to the model. Well, in our case, let's go on here and import Ollama. So I want to get rid of this message. I'm not going to send that message back anymore. Instead, I'm going to exactly the same as here, wait for the Ollama chat, and where the model is the model that we just downloaded and pulled. So let's see our models list. So if you do Ollama list, you can see the models, and this is the name of the model that we need. And of course, just go on and then do configuration. Your service can be generic and run with different models. So you can just put this into your environment variables and then just read from there. And my messages is simply going to be the messages that I get from my HTTP context. So here I have the role user and the content. Let's just check here again. The content is going to be the HTTP context payload.message. Well, this is it. It is going to give you the answer, but it is not going to have that nice effect for streaming. For having the stream effect, there is a stream flag you need to set, which is here. So let's actually go on and set that. Well, what this means is that now inside the response, there are some chunks which you need to wait for. Let me go on and then change this a little bit. I'm going to call this chunk. Now here you have to wait for this response. So because this response now is a wait and it is chunked, and you have to wait for each stream output. I am going to keep this delay because I want to see the output getting streamed, because sometimes it goes really fast when the model is also a little bit smaller. And now I'm going to say write chunk dot message. So now this has to actually give us the reply from the model. So let's go on and then run this again. And then let's run this. Let's see just what will happen. Must be trying to string. Yes, so this has to be content. As you see, now the answer is coming from the model. I'm happy to help, but it seems that you didn't finish your question and so on. Well, this is nice. I would say now let's go on and give it a UI. So here I also have a UI already prepared, but it really doesn't do anything right now, so it will wait forever. So let's actually see how can we handle this streaming now in the UI. You can also go on and then use WebSockets, but here I'm trying to use the server-side events because this is the same in ChatGPT. If you open ChatGPT under network, you will see that it is also streaming events. Therefore, yeah, why not? We are going to have the same logic, and it makes sense because it's in a simple definition here, and you really don't need to open a WebSocket request here. So it makes more sense. My application, my Vue application, is combined of a chat panel where the history of the chats are and the chat input inside the index page. So everything that you're seeing here is basically this one. So now let's go on and send our request, the same as we did in curl. So to do that, here we are going to make our fetch here. Let's actually first make our fetch request and then console log it, and then we are going to show it in the UI. So to do that, I am going to use fetch because the streaming on Axios really doesn't work here. On Axios, it doesn't really give you the access to the reader. Therefore, you have to use fetch in this case. Yeah, so this and I don't think if this is going to be an issue. You can just have a component for the streaming and or a composable which you can add, and it uses fetch for the SSE. And here I'm going to have this async. My method is post to this endpoint. There is an application JSON, and this is how my payload is going to look like. Of course, after I send this, I want to have the model go away. And well, it is not yet time to have the sending false, because here now I want to check if the body exists. And if the body exists, I want to say get the body reader. So give me the reader from the body. So the reader contains all of the binaries that, like the blobs, have came back from the backend, and now we have to decode them to have a text. Let's have this as UTF-8. And now here I'm going to have while true. Yeah, the same here as mentioned by Copilot. We are going to deconstruct this and then get done and value. Done is going to where the response ended. We know it's done. And when done, we are going to break this loop. And now let's actually decode this. While decoding, I am also going to set the stream of the decoder to true. And now let's see what will happen with this. After the while is done though, I want to say sending value back to false. So let's come back here and inspect elements, go to console and say, can you introduce yourself? And if I have this to the right side here, yeah, so as you see, it has streamed the data back here. Now let's actually go on and show it in the UI. Now, what is happening here? What I want first is that the message that I am removing here has to go back to the chat panel to have this right to left, my chat, his chat effect in the UI, and that I know which chats are mine, which chats is from the AI. So in that case, I'm going to add some events to my component. So in this case, I'm gonna call it message. Oh no, sorry, I'm gonna call this message, and the message is going to get a chat type, and there's no output. So in this case, it is going to be right before this. Yeah, so emit message, no, the role is going to be user. Well, one thing about the roles that you need to know, also you saw it in the backend, there are 3 roles in Ollama SDK for the chat. One is user, assistant, and there is system. The user, I guess, is obvious. This is the user who is sending a message, so the AI knows whose message has this been for. And the other one is assistant. This is the AI's message, which has been generated. And there is the system role. These are like the configuration which you give to the AI model in advance, for example. This is for prompt engineering. But we are going to check that later. Just for now, have in mind what does the role mean. Now I am emitting my message here. Now let's go on and then see what should happen to this message. So this is the message. What happens is that I have to actually simply just push it to my chats. So here I just want to push it to my chats. The chats are going to the chat panel, and here, as you see, the chat panel is already going through these chats. By the role, it is rendering the chats. For the AI, when the role is assistant, it is converting it to a markdown and then showing it. For the user, it's setting it to chat assistant and has a specific styling. Yeah, so now let's go on and then see how now this looks like. Chat input, I guess, is here. Okay, so hi. Yeah, as you see, we wanted this. There is an answer, but we don't have the answer yet. So now let's go on and continue with the rest of the configuration. Let me move this somewhere else. Okay, so what else do we want? We want to also return this streaming, which we are doing console log here. So what I want to do is that I'm going to say const chunk is equal to my decoded message, and don't console log it, instead emit it. So there's going to be a string event, for example, the chunk, and here I'm going to say emit stream and the chunk. And at the end, what you want is that also is better to also say, hey, I am done. So the messaging is done. So let me go on and then also do that. I will show you why I need this. Because like here, what happens is this. So when I do the stream, I have to now add a new ref for my streaming. This ref, this one actually going to be used here. Okay, so now let's go here and see how is this used. This is like the temporary message, right? So as this is being streamed, I want to show this. And after it is shown completely, I want to set this to empty because it has a temporary paragraph for this, and then add it to the chat so it is still visible, but it is not in the draft area, let's say, anymore. So for that case, that's why I have the done. And for the stream, I'm going to have say handle stream, and then I'm going to receive the chunk, and then I'm just going to add it here. And here I'm going to say handle done, and this is going to handle done, and I'm going to have the streaming message here, completely set it, push it into the chats with the assistant role and set it to empty. So let's go on and say handle stream here, and for the done, say handle done here, and let's go on and see how it looks like now. Hi. Yeah, so as you see, now it's working as expected. Now let's see how smart is this. I'm making a YouTube video about you. Let do you think about it? What do you think? Or how do you feel? Yeah, I mean, it is still smart enough, right? Because we have downloaded a very small Ollama model, the 3B model, and it is still verbal, like verbal, I mean, it can talk, like text you, and it probably can do a lot of stuff. But this is something that you have to go on and try by yourself. But for now, let's go on and see how can now we tweak it. Because for example, if I ask, introduce yourself, model designed to assist. Yeah, it's not the personal one, but I can suggest names. So, okay, but I want to give it a name, right? So what do you think about Jarvis? Okay, let's call him Jarvis. But how do we do this? Well, it is here, where you are going to send the messages. Here, well, as you see, you can come with the idea yourself, right? If you have a smart model, or you have trained the model and you know how the behavior of the model is, you can give certain prompts in advance to it, so it can understand certain things. You can give it a role. For example, you can say, hey, you are a doctor, or for example, you can say, hey, you are a comedian, and this is your name, right? But here I'm going to let's give him a name. You are a personal assistant. Your name is Jarvis, and your name, your owner's name is Tony Stark. Okay, now let's see what will happen. If I go back to the model, can you introduce yourself? As you see, now it knows about I'm Jarvis, Tony Stark, trusted AI assistant, and things like this. So now you can actually go on and play around with this. One other thing which is going to be interesting for you to know is how you can actually have a bit of a memory for it. So because, for example, if I talk to it right now, if I ask, can you tell me what we have talked about so far? It says we haven't discussed anything yet, right? So how does that work? It has to have these somehow, right? Well, this is where, that's why, I mean, you can use a service in the middle like Node.js, Python, whatever. Store your chats in a database, and every time just read from that database and push this in advance, and then append your new message. So let's go on and do that. Well, now this part is not really specific to AI. We are going to check how we are going to feed the AI from the database, but I want you to get creative, right? So put ideas in your mind. For example, what else you can do here? For example, you can have TTS. You can have a text-to-speech model running on a Raspberry Pi, which is going to contact your server here and just get the text and have it as a voice there. You can have your own Alexas at home, right? Like you are not being listened to by this guy. Well, what else you can do? For example, you can have an OCR service, which is going to read the texts out of an image, and you can feed it here for free. And when we actually go on with the videos, and I will go on through how to train your own model for certain things, then you will get more ideas. And don't worry, in those videos, I'm not going to talk about how to train a model to detect fraud in a big bank database. No, that's lame. I'm going to actually use very cool examples. But for now, let's go on and see how are we handling the databases. In Node.js, I am using Prisma. I'm defining my models in Prisma. It's a schema first, ORM for Node.js. I have a chat model. The chat model has a role and has a message, and the role is user and assistant. And now let's go on and read these chats. What we want is that we want to get the chats, doesn't matter, based on assistant and role, and then feed it to our AI. So here I'm going to have the chats, read Prisma, chat, find many. I don't care about which chat. If I was using authorization, perhaps I would have cared about which chat I want for which user. But here I don't have a user. I want the chats to be ordered by their created ad incrementally. So I need to map this to the model from Ollama. So let's see how correct is this. Yeah, it looks pretty correct. Yeah, that's fine. I want to put it here. So this is before the new message and after the system messages. But I want to add a new message here to our model and tell content. You also remember things. So every time a new message given to you, every time you are processing messages, the last user message is the recent one. So process all your messages and their messages to give better responses. So this way now it kind of have a memory, right? And other interesting thing is that to build these prompts in advance, you can actually be creative and use, for example, Elasticsearch and put all of your data from everywhere into Elasticsearch. And based on the user's input, you do a search first in Elasticsearch, you do a full text search, you're going to get a lot of documents back from Elastic and push all of those documents here. So then your AI is going to be tuned towards a certain question. For example, if someone asks about, give me a diet plan, you are going to search in the Elasticsearch based on this give me diet plan, and Elastic is going to give information like whatever your data classification is, and then send it into your prompts, and then you can prompt engineer it, right? So this is how you can do this without fine-tuning the model. So you don't really need to train here. You can just use prompt engineering to head the model towards certain things. But of course, fine-tuning is necessary or needed if you want to teach certain new things and skills to your model. For example, you want to enhance, I don't know, writing code for you in Python. Yeah, so this is how it works. Like, for example, want to detect a cancer cell on a certain part of the image, for example. But this is not about the transformer model in an image processing model, but I'm just giving you the ideas of like this, how, because these different terms are used in the other videos, but the use cases in practice maybe is not clear. So this is how they are built, and it is not always just one single model. All applications having a lot of different models are working together. So this is also something else to have in mind. And now let's go on with this, and you're missing something here. I talked a lot. So here what we need is to store the chat. So we need to store our chat and the chat from the AI. So what we want to add here is that AI response, and this is string. This is overkill, but yeah, let's do this. And what I want is that this is actually let, and every time that I am sending this, I'm also going to store this, and at the end I want to exactly do this, but I want to create many. So I want to create many of this. This means that I need please. Yeah, nice. So this is actually system. Oh, let me see. Yeah, this should work, but this is assistant. And this is the AI response, and the other one is, yeah, okay. So first, the user response has been there, and then the response from the AI. Now let's save this and go on and chat with it. Hello, my name is Farhad. Who are you? So personal assistant, highly advanced AI. It's gonna probably talk for a while. Okay. Now let's see what happened in the database. Let's just rerun this. As you see, I have the data already. Yeah, I have a slight issue, and that is that the created acted at the same time, and it may cause some issues in the ordering. Therefore, I would rather to have a custom created ad. So I would say const instant new date, and then I'm going to say the created ad of this one is at that time, and here I'm going to say, can I get time? And then say new date. There we go. Now this actually has to kind of fix this. So let's go on and ask something else and see. Hello, my name is Farhad. Who are you? And let's see, nothing here yet because it's still streaming. Okay, yeah, so now it's going to be sorted better. And let me check again. Yeah, so this comes first and the assistance comes the second. Do you know my name? I do remember your name, Farhad. So this is now, okay. Can you give me examples of a C# application? Iron Man suit control system. Since we have already told it that you're Jarvis, then it has already got information about Iron Man. Yeah, but cool. So this is actually how you can have fun with an AI model and just run it by yourself. Okay, so I didn't want to end the video as I always do with a full screen camera. I went on and then talked with Jarvis a little bit, and once I recorded the video and told it to say goodbye and just said goodbye to me, and then I clarified to it, no, say goodbye to everyone and don't forget to subscribe or like the video. And now it is clarifying that, okay, do you mean that I have to wait until I say that? Exactly, it's really polite. I like Jarvis already. So let's go on and end the video and give the honor to Jarvis. So now we can end the video. Yeah, this is a tech-tastic content. Now this is my new slogan. I don't know if that's a word, but it works. Well, as Jarvis said, don't forget to subscribe or like the video if you like the content. There are gonna be much more content like this on how to train your model, how to work with these models, how to deploy these models, and so on. With that being said, I wish you have a lot of fun in coding. And until next time, cheers.